Hello everyone, I'm Divya, your math facilitator. So we have started Abyasa Deepika questions and you asked me trigonometry questions first. So as a part of this series, we are firstly going to learn trigonometry questions. Okay. In trigonometry also, we are going to learn the essay questions first. Okay. So prove that questions where you have major problem. So today we are going to discuss 8 questions which are very different and solving these questions will definitely give you a lot of confidence. Okay, so let's begin the session. So the very first question is here. So all these are the questions from Abyasa Deepika. Okay, so the very first question is here. If tan theta is 1 by root 7, find the value of cosecant square theta minus secant square theta divided by cosecant square theta plus secant square theta. Okay, so whenever you have a question like this, whenever you find a question like this, firstly see whether you can apply any identity. Okay, wherever trigonometry question is there, the first step you will do is you will check if there is any identity. Okay, so always first step is check for the identity. If you find any identity, please apply the identity. Otherwise, please convert everything to sine and cos. Now here in questions like this, where value of one trigonometric ratio is given to you. For example, here value of tan theta is given to you. So in this type of question, you can directly apply Pythagoras theorem instead of thinking of what to prove, because here you are not proving, actually you are just finding the value. So in these questions, directly you can apply Pythagoras theorem. Okay, so there are few questions where you can simplify and then apply Pythagoras, okay, to minimize the steps. But if you have no time to think of what to do, you can simply blindly apply Pythagoras theorem. Okay, so let's do this. So I want all of you to do along with me. Take your pen and book, try to solve it and try to see whether you are able to do it or not. Okay, so here what is given to us, tan theta equal to 1 by root 7. So we know tan theta is nothing but opposite by adjacent side. So if I take a right angle triangle, if this is theta, so this is the opposite side and this is the adjacent side. So I know tan theta is nothing but opposite by adjacent. So I can take from this, I can conclude that opposite side is 1k unit or simply k units. Adjacent side is root 7 k units. K, where k is any constant. Whenever there is a ratio, common factor, okay, could be cancelled off. So this is the simplest term. So when you take the corresponding parts, you always take along with the common ratio. So here I am taking opposite side as k units and adjacent side as root 7 k units. Now you will simply apply Pythagoras theorem. So applying Pythagoras theorem, I know hypotenuse square equal to opposite side square plus adjacent side square. So hypotenuse square is equal to opposite side is k square plus adjacent side is root 7 k whole square. So this is k square plus 7k square. So this is total 8k square. Or I can write this as root 8k. Okay, hypotenuse square is this, so hypotenuse is root 8k. Now we need to find the value of cosecant square minus secant square upon cosecant square plus secant square. So cosecant square theta minus secant square theta. So for that, firstly let me find the value of cosecant and secant. Okay, cosecant is the reciprocal of sine. So sine is opposite by hypotenuse. So cosecant is hypotenuse by opposite. Hypotenuse side is root 8k and opposite side is k. So cosecant theta is root 8. Now secant theta is the reciprocal of cos theta. So cos is adjacent by hypotenuse. So secant will be hypotenuse by adjacent. So hypotenuse is root 8k and adjacent is root 7k. So k cancel. This is root of 8 upon 7. Now the next step is simple substitution of the values. Okay, so how will you substitute the values? See here, the given question is you need to find the value of cosecant square theta minus secant square theta whole divided by cosecant square theta plus secant square theta. So this is nothing but cosecant is root 8. So root 8 whole square minus secant is root of 8 by 7. K gets cancelled. The common ratio gets cancelled. Whole square by root 8 whole square plus root of 8 by 7 whole square. So squares and square root gets cancelled. So this is what you have. When you take LCM, this is 8 sevens of 56 minus 8 by 7. 56 plus 8 by 7. So 7 will get cancelled. So 56 minus 8. So how much am I getting here? So simple 48 by, so this is 64. 48 by 64, again in 8 table it will get cancelled. So 8 6 are, 8 8 are, or actually direct 16 table we can take 3s are, 4s are. So 3 by 4 is the answer. So this way, simply using Pythagoras theorem, you can calculate what is the value of this. Okay. So cosecant square theta minus secant square theta by cosecant square theta plus secant square theta. So now let's proceed to the next question. Prove that sine cube theta minus cos cube theta whole divided by sine theta minus cos theta plus sine cube theta plus cos cube theta divided by sine theta plus cos theta is true. So whenever you find a question of this type, so they are asking you to prove that. What is the first thing I asked you to do? I asked you to check for the identity, isn't it? What did I ask you to do? Simply check for the identity. Okay. So see here, is there any identity? Your eyes should directly recognize the identity. See here, there is an identity. A cube minus B cube. Sin cube theta minus cos cube theta is like A cube minus B cube. What is the identity? It is nothing but A minus B into A square plus AB plus B square. Okay, there are some identities which you need to remember, which is very useful for trigonometry. And then the next one is A cube plus B cube. This is sin cube theta plus cos cube theta is like A cube plus B cube. So the identity is A plus B into A square minus AB plus B square. So people compare the identity and check. And two more identities are A square plus B square or A plus B whole square also you can learn, which is nothing but A plus B whole square minus 2AB. This is nothing but A plus B whole square equals to A square plus B square plus 2AB. This 2AB only, if you send it to other side, you will get this identity. Okay. Another identity is, you know, A minus B whole square. It is A square plus B square minus 2AB. So this minus 2AB, if I transpose to the other side, I will get A minus B whole square plus 2AB equal to A square plus B square. The last important identity is A plus B into A minus B is equals to A square minus B square. So no confusion people, I'll make it more simple for you. So this is one identity you will learn. A plus B into A minus B is A square plus B square. Yes. A plus B into A minus B is A square minus B square. And then you have this one. A plus B whole square is A square plus B square plus 2AB. A minus B whole square is A square plus B square minus 2AB. These three identities which you have been learning from childhood. So these you will learn again. And along with that, A cube minus B cube, A cube plus B cube. Okay, these are most important. And sometimes you may also need this identity, A plus B whole cube and A minus B whole cube. Okay, I'll make a separate video, a short video on the identities. So A plus B whole cube, A minus B whole cube also sometimes you may need. So here, if you identify what is the identity I need, A minus B whole cube and A plus B whole cube. Okay, so I know A minus B whole cube is A minus B into A square plus B, AB plus B square. And A cube plus B cube is A plus B. Okay, if you have plus C here, A cube minus B cube will be, here minus is there. So you will write A minus B into A square plus AB plus B square. So if you are taking minus here, here everything will be plus. A cube plus B cube is nothing but here you will have plus a plus b into a square plus b square. It will be minus ab here. Here if it is plus, this ab term will be minus. Okay, this much if you are able to remember, then you can do the problem. Okay, so I'll just help you to substitute also here. See, so we know the identity now. We know a cube minus b cube is this much. Okay, so the first term given is sine cube theta minus cos cube theta. So sine cube theta minus cos cube theta is like a cube minus b cube. So here in this place of a I have sine, in the place of b I have cos cube theta. Cos theta. Okay, in the place of a I have sine theta, in the place of b I have cos theta. So if I have to substitute, what is a minus b then? A is sine theta, b is cos theta. So a minus b is sine theta minus cos theta. Similarly, a square means sine square theta plus ab means sine theta into cos theta plus b square means cos square theta. That is equal to sine theta minus cos theta into sine square theta plus cos square theta is how much now? Sine square theta plus cos square theta will give me 1. Isn't it? That is an identity. So 1 plus what is remaining? Sine theta cos theta. So this much is the value of whom? Sine cube theta minus cos cube theta. So this is one value which we are getting. Okay, so just have a look here now. So I just got the value of sine cube theta minus cos cube theta. Now also I have this sine cube theta plus cos cube theta. So we know that a cube plus b cube is a plus b into a square minus ab plus b square. Okay, so sine cube theta plus cos cube theta is nothing but sine theta plus cos theta into sine square theta minus sine theta cos theta plus cos square theta. So that is again equal to sine theta plus cos theta into sine square theta plus cos square theta is 1 minus sine theta cos theta. So this is the value of sine cube theta plus cos cube theta. If you are able to do this much, then the next step is simple substitution. So how are we going to substitute? See, my LHS given is, just look at the LHS. So you have sine cube theta minus cos cube theta whole divided by sine theta minus cos theta plus sine cube theta plus cos cube theta whole divided by sine theta plus cos theta. But we already know the values of the numerators. Sine cube theta minus cos cube theta. So what is sine cube theta minus cos cube theta? Sine theta minus cos theta, this one. So it is nothing but sine theta minus cos theta by 1 plus sine theta cos theta. So let me substitute here. Sine theta minus cos theta into 1 plus sine theta cos theta whole divided by, denominator is sine theta minus cos theta plus sine cube theta plus cos cube theta is nothing but, see, this value. Sine cube theta plus cos cube theta is this value. So it is nothing but sine theta plus cos theta. You have it as sine theta plus cos theta into 1 minus sine theta cos theta whole divided by, denominator is sine theta plus cos theta. Now if you clearly observe, the numerator and denominator here gets cancelled. So here sine theta minus cos theta, sine theta plus cos theta and sine theta plus cos theta. So these are getting cancelled. So what is remaining here in the first term? It is 1 plus sine theta cos theta. In between you have a plus sign, so I am writing that. Then what is remaining here? It is 1 minus sine theta cos theta. Now sine theta cos theta minus sine theta cos theta cancel. So 1 plus 1 gives me 2. 2 is nothing but the RHS. Understood? So see how easy it was once you know the identity. Okay, so don't forget to learn this identity. So question number 3, secant theta plus tan theta is P. Show that sin theta value is P square minus 1 by P square plus 1. So it is given secant theta. What is given to you? Secant theta plus tan theta is P. Now you need to find the value of sin theta. But unlike the first question if you see in the first question, they gave you tan theta value. But here secant and tan together is given as P. So whenever you find such type of questions, try to identify whether there is any identity or not. So if you clearly see here, secant theta plus tan theta is P. So secant theta and tan theta together you have one identity. Do you remember what is that? Secant square theta minus tan square theta is 1. So what is the identity which we know? We know already. We know that secant square theta minus tan square theta is 1. Now just now I told you identities of algebra also. What are there? I already told you a square minus b square is a plus b into a minus b. A square minus b square is a plus b into a minus b. So using this identity here, see this is like a square minus b square. So can I write it as a plus b into a minus b is equals to 1. If you clearly see now, I just know secant theta plus tan theta value, which is P, into secant theta minus tan theta equals to 1. Now, secant theta minus tan theta value is nothing but 1 by P, transposing P to the other side. So, this is equation 2 I can take. Let me take this as equation 1. So, this model whenever asked, this is the only method you can do. Now from this I can write secant theta plus tan theta is P, and I also got secant theta minus tan theta is 1 by P. Also people, there are shortcuts which you need to learn if you are applying for any entrance examination. So then I will give you separate coaching for the shortcuts, okay? So here you see, if I add these two equations, what will happen? Tan plus tan theta minus tan theta gets cancelled. Okay, I have secant theta plus secant theta is nothing but 2 secant theta is equal to P plus 1 by P. So, secant theta value I got it as, see, taking LCM, this will become P into P is P square plus 1 by P. And here I have 2. So, 2 secant theta is this. So, secant theta is P square plus 1 by 2P. Okay, so here I just got secant theta value. So, one trigonometric ratio I got. So, from this I can also write cos theta is nothing but 2p by p square plus 1 secant, and cos are reciprocal of each other. Now, once you got cos value or secant value, you can use Pythagoras theorem and find sine value. This is one method. This is one method. Other method is, I know cos. From this equation, I can find tan. And tan is nothing but sine by cos. So, from that also I can find sine value. I will show you the second method, because Pythagoras theorem you all can apply. Because see here, this is nothing but adjacent side by hypotenuse. So, which means you will take adjacent side is 2p k units and hypotenuse is p square plus 1 k units, and you will find what is the opposite side using Pythagoras theorem. Okay, and substitute. So, this is one method. Okay, so I am using the second method. What is the second method now? I found a secant theta value. Okay, this method you can do it by yourself. So, just concentrate on the second method. I found secant theta value. Now, substituting secant theta value in equation 1 or 2. It is simply like your pair of linear equation. Once you get x or out of x and y, if you get x or y value, you substitute that value in any one equation to get the other variable. So here also the same thing. Here our variables were secant theta and tan theta. So I got secant theta. I am substituting secant theta value in any one equation to get tan theta value. Okay, so I'm taking equation number 1. So equation 1 is secant theta plus tan theta equals to P. I will also provide the notes of this in Math Facilitator website. So you can just go through it once after this. Okay. And you will also have practice questions in Math Facilitator website. So you can just open, it is all free, completely free. You can open it, click on the link and practice those questions, mark the answers. You will get the score then and there. You can check your understanding there. Okay. So lot of questions, if you practice, you will get more score and more experience in solving the questions. So do visit Math Facilitator website. So yes, and the link is given in the description box also. You can go. Now see, secant theta value is what? Secant theta is p square plus 1 by 2p. So substitute that value, plus tan theta equals to p. So what is tan theta now? Tan theta value is nothing but p. If I take this entire term, if I am taking to the other side, it becomes minus p square plus 1 by 2p. Now taking LCM, so p into 2p is 2p square minus p square plus 1 by 2p. So you should know how to take the LCM here. So 2p square minus p square minus 1 by 2p. So that is nothing but p square minus 1 by 2p. So what is this value I got? Tan theta value. Now see here. We know tan theta is nothing but sin theta divided by cos theta. So I want sin theta value. So sin theta, can I write it as tan theta into cos theta? See, taking cos theta to the other side. So sin theta is nothing but tan theta into cos theta. So see here now, I want sin theta value only. So tan theta is p square minus 1 by 2p into cos theta is how much? See here, cos theta you got 2p by p square plus 1. Got it? So 2p cancels here. So your sin theta value is p square minus 1 by p square plus 1. Just check, is this what you have to prove? Yes. So I have used the second method. Okay, I found secant theta, I found tan theta using the identity secant square theta minus tan square theta. And then I substituted, I know the relation between tan, sin and cos. I know tan theta is sin theta by cos theta. So I substituted the value and I got sin theta value. This is first method. Second method is, you will do till here. All these steps you will do, you will find secant theta, you will find cos theta also if you want. Then use Pythagoras theorem. Okay. See question number 3. Prove the following. Again you have to prove this. So what is given to you in the LHS? Just have a look. LHS. So think how you can do this. What can be done here? Cos A by 1 minus tan A plus sin A by 1 minus cot A. So I told you first try to check for the identity. Take the LHS first. See always now again. So there is no rule that you should take only LHS first. You can take RHS also. So how you will choose whether you have to take LHS or RHS? It depends on the question. Okay. So whichever side you can solve more, that side you will choose. For example, in this question, I have many things to solve here, but nothing to solve here. Cos A and sin A is already the simplest form. There is nothing to solve here. So, wherever I have the chance to solve, that side I have to take first. Okay. So, here as you can see, LHS is the place where there is possibility where I can solve something. So, I am taking LHS. So, LHS is cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A. Okay, so this much is done. So, now second step is, I don't find any identity here. There is no identities. We know sin square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. Nothing I am finding here. Also, a minus b whole square, a plus b whole square, a square minus b square, nothing I am able to find here. Okay. So, when nothing is there, when there is no identity which you are able to find, then the next step is you will convert tan, cosecant, secant, cot into sine and cos. Okay, you have 6 ratios, isn't it? What you have? Sine, cos, tan, cot, cosecant and secant. So these 4 ratios you will convert into sine and cos. Understood now? So here you see, I have cos A divided by 1 minus tan A is nothing but sine A by cos A. So I'm just converting in terms of sine A and cos A. So sine A you will write as it is, 1 minus cot A is nothing but cos A by sine A. Did you all understand till here? Just convert it. Just convert it. Once it is done, now see, you can take LCM. So once you convert, you will get the next step. You can take LCM. So it is cos A divided by LCM in the denominator. So it is 1 into cos A is cos A minus sin A divided by cos A plus sin A. So here also LCM will be sin A. So sin A minus cos A by sin A. Now see, we all know how to solve fractions. So here you have fractions. The fraction is in the denominator. How is this fraction? This fraction is in the denominator. So when it goes up, it will reciprocal. So cos A comes up and cos A minus sin A will remain in the denominator. You have a plus in between. Then you have sin A, and similarly the next term also sin A comes up and sin A minus cos A will remain in the denominator. So these are the two things I have, two terms. Okay. Now cos A into cos A is cos square A divided by cos A minus sin A. Sin A into sin A is sin square A divided by sin A minus cos A. So cos square A whole divided by cos A minus sin A. Now if you just observe both the denominators, observation is very important in trigonometry. If you observe the denominators, you see denominators are same. Denominators are exactly the same. So cos A minus sin A minus cos A. What is the difference here? Just a minus sign. Okay, so here cos A is positive, sin A is negative. In the other term, sin A is positive, cos A is negative. So simply if I take minus common here, okay, if I take minus common instead of plus, if I take minus, so here I can write sin A minus cos A, the sign will change. Okay, so after this, just look at the step, you can take LCM. So what is the term you can take LCM? These are like fractions, isn't it? So directly sin A, see cos A minus sin A I can take. So LCM would be directly cos A minus sin A because these are like fractions. Okay, and the numerators also as it is I can write cos square A minus sin square A. Now if you observe the numerator, see the numerator, it is like A square minus B square. Numerator is A square minus B square. It is nothing but A plus B into A minus B whole divided by cos A minus sin A. Did you all understand till here? So, directly I can see that I can cancel the denominators cos A minus sin A, cos A minus sin A. So, what is remaining after I cancel? What I want. What I want? Cos A plus sin A. This is nothing but my RHS. Clear people, I am going very slow so that you understand the logic of why are we doing a particular step. Okay, please don't by heart. Listen to the explanation, understand the logic. Okay, see the next question. Secant theta plus tan theta minus 1 by tan theta minus secant theta plus 1 equal to cos theta by 1 minus sin theta. This is what I have to prove. Already I told you, wherever the possibility of solving is there, you will take that. So out of LHS and RHS, I find LHS is more complicated. So that complicated part I can solve. So I'm just taking the LHS part. So LHS is secant theta plus tan theta minus 1 by tan theta minus secant theta plus 1. So here when I am finding this question, I need to remember there is one question given in our textbook also. So where they are asking us to use the identity secant square theta minus tan square theta. Here secant theta and tan theta has a relation between each other. We know secant square theta minus tan square theta is 1. So here I am using that identity. Okay, so what I am doing is, okay, because I know the identity, so I am able to identify the identity. Are you able to understand? What is the first step? Identify the identity. So here I am able to identify the identity. So I am converting this 1 into secant square theta minus tan square theta. You might ask me, why only secant square tan square? I can also convert it as cos square plus sin square. You can convert it, no problem. But converting into cos square sin square is useless for you, because what is given to you here is secant theta and tan theta. So it is, you know, good to see what is given to you, what you want. Accordingly, you will take steps. Okay. So here 1 I wrote it as this one, I wrote it as secant square theta minus tan square theta. In the denominator, I have tan theta minus secant theta plus 1. Okay. Now see here, I can write this as secant theta plus tan theta. Now I find one more identity here, minus, this is like a square minus b square. So I can write it as a plus b into a minus b whole divided by tan theta minus secant theta plus 1. If you just see here, yes, this is completely one term. This total is one term. You have a minus sign in between. Okay, out of these two terms, what is common is secant theta plus tan theta. Secant theta plus tan theta is common. So when I take secant theta plus tan theta common, what is remaining? What is remaining? See, if I take secant theta plus tan theta as common, okay, so from the first term, nothing is remaining. So I write 1 minus, from the second term, secant theta minus tan theta is remaining. So whenever minus is there, it's good to place a bracket and then solve it in the next step. Denominator take as it is. So secant theta minus tan theta, tan theta minus secant theta plus 1. So see here again, so secant theta plus tan theta. Let me simplify the numerator. It is 1 minus secant theta plus tan theta. Minus was common, isn't it? Divided by tan theta minus secant theta plus 1. If you just observe the numerator and denominator, see here, tan theta is there, tan theta. Minus secant theta minus secant theta plus 1 plus 1. So these two terms are same. You can cancel it out. So what is remaining is secant theta plus tan theta. What you have finally is secant theta plus tan theta. But what you have to prove, go back to the question and see. What you have to prove is cos theta by 1 minus sin theta. Okay. So I am taking what I got finally secant theta plus tan theta, but I want in terms of cos theta and sin theta. So convert secant theta in terms of cos theta. So it is 1 by cos theta. Tan theta is sin theta by cos theta. Taking LCM, see cos theta like fraction. So directly I can take this. But this is also not there. This is also not there. Cos theta by 1 minus sin theta I want. I got 1 plus sin theta by cos theta. So whenever you find like this, see here, what logic you need to remember is, here you have 1 plus sin theta in the numerator. You have 1 minus sin theta in the denominator. So in this case, always remember that we need to have 1 minus sin theta in the denominator. So here I have cos theta. Remember that you can use the identity cos square theta plus sin square theta is 1. So from this I can write cos square theta is 1 minus sin square theta. Isn't it? Cos square theta is 1 minus sin square theta. So here, if I want to write 1 minus sin square theta in the denominator, I want one more cos theta. So I am multiplying and dividing by cos theta. Okay. So I'll explain you this step again also. So as of now, see here. So when I am simplifying, I get this divided by cos square theta. You might be wondering why only cos square theta. I'll tell you. Divided by cos square theta, I can write as 1 minus sin square theta. So this is again like a square minus b square. So I can write this as 1 plus sine theta into cos theta divided by a plus b into a minus b. So 1 plus sine theta, 1 plus sine theta cancel. So numerator you have cos theta, denominator you have 1 minus sine. This is what you have to prove. See, cos theta by 1 minus sine theta. Got it, people? So what logic I have applied here is, see here. I have 1 minus sine theta in the denominator and 1 plus sine theta in the numerator. So, which means 1 plus sine theta in the numerator should get cancelled. From where will I cancel 1 plus sine theta? There is nothing to simplify here. So, which means in the denominator also I want 1 plus sine theta. Are you able to understand? See, I have this 1 plus sine theta by cos theta. But what I want is in the denominator I want 1 minus sine theta. Okay, and numerator 1 plus sine theta is that this I to cancel I want 1 plus sine theta in the denominator. Okay, so if this is what I want and this is what I want, these two I want. So if I combine these two, it is nothing but 1 minus sine square theta. 1 minus sine square theta means cos square theta. So this is what I want in the denominator. So cos square theta I want, but I have only cos theta. So that is the reason you have multiplied and divided by cos theta. Understood, people? So what you want will always give you the clue, provided you concentrate little on the question and try to understand what we are doing instead of by hearting. Please never by heart trigonometry questions. Not only trigonometry, any question you should not by heart. But here particularly, if you by heart, you cannot do a new question given to you. So always remember this. Okay. So we have proved that. Now see the next question. Can you recollect any question of this type? Cosecant theta plus cot theta is k. See, we have done one question in the session only. Secant theta plus tan theta is p. There I told you there is a relation between secant and tan. So secant square theta minus tan square theta is 1. Here also there is a relation between cosecant and cot. Cosecant square theta minus cot square theta is 1. So let's use the relation. This is same model question. Nothing new. Same model question. Same. So cosecant square theta, we know that cosecant square theta minus cot square theta is 1. So cosecant square theta is nothing but cosecant theta plus cot theta into cosecant theta minus cot theta is 1. So cosecant theta plus cot theta is nothing but k. It is given in the question only. So cosecant theta minus cot theta is 1. So what is cosecant theta minus cot theta? It's nothing but 1 by k. So this is your equation 2. This is your equation 1. So solving both the equations, just add equation 1 and 2. So these two gets cancelled. Cosecant cot theta plus cot theta minus cot theta. So you have 2 cosecant theta is 1 by k plus k. Or you can write cosecant theta is nothing but if you take LCM, it is k square plus 1 by 2k you will get. Okay, this 2 also I took it to the other side. Directly in one step I have done. Okay. So I got this value. Now I can find sine theta. Sine theta is nothing but reciprocal of it. So substituting cosecant theta in any one equation. Here again there are two methods as I already explained you for secant theta tan theta question. So you can use Pythagoras theorem here to find cos theta. Otherwise what you can do here, see, substitute cosecant theta. Okay, substitute cosecant theta value in equation 1 or 2. Okay, so cosecant theta plus cot theta is k. Cosecant theta plus cot theta is k. Cosecant theta is how much? Cosecant theta is k square plus 1 by 2k plus cot theta is k. So cot theta value will be k minus k square plus 1 by 2k. So taking LCM, it is 2k square minus k square minus 1 by 2k. It is similar to the previous question. So I am doing it little quickly. Okay, so this is cot theta value I got. Okay, so cot theta is k square minus 1 by 2k. Understood? Now we know that. See, I need to find cos theta value. But I know cot theta is nothing but cos theta by sin theta. I have sin theta value also. I have cot theta value also. I want cos theta value. So cos theta is nothing but cot theta into sin theta. Cot theta is k square minus 1 by 2k into sin theta is 2k by k square plus 1. So 2k cancel. So k square minus 1 by k square plus 1. That is cos theta value. Cos theta. So if you see this question and the previous question, I'll show you. This question, third question, are of the same model. Okay. We are solving it using the same model. Just the equations are different. Okay. So do practice this. Now see the last model given in Abyasa Deepika. Proof that root 1 plus cos theta by 1 minus cos theta is cosecant theta plus cot theta. Always remember whenever this model question is given. So they may give you root 1 plus cos theta by 1 minus cos theta is something, or they may give you root 1 plus sin theta by 1 minus sin theta also, same model. Okay, so whenever you find this question, remember that you need to rationalize. Here identity you cannot apply, you cannot do anything. You need to rationalize. Okay, so here square root should get cancelled. So only method is rationalizing method. Clear beta? So now see what we can do here. So I have my LHS is root 1 plus cos theta by 1 minus cos theta. So rationalize the denominator. How will I rationalize? Denominator is 1 minus cos theta. So you will write 1 plus cos theta in the numerator and denominator. So multiply and divide by 1 plus cos theta. So here that is equal to root of, see this is like 1 plus cos theta into 1 plus cos theta. So I can write as 1 plus cos theta whole square. It is like a into a square. So 1 plus cos theta into 1 plus cos theta, 1 plus cos theta whole square divided by a minus b into a plus b. So a square minus b square. So that is equals to root of 1 plus cos theta whole square divided by 1 minus cos square theta is sin square theta. Now you see numerator and denominator have squares. So I can simply write this as nothing but 1 plus cos theta by sin theta whole square, because numerator and denominator both have squares. Now square and square root gets cancelled. So finally I have 1 plus cos theta by sin theta. Okay, our aim was to remove the square root by rationalizing. So it got cancelled. Now I want cosecant theta, cot theta, but I have something in terms of sin and cos. Separate the denominator. So 1 by 1 plus cos theta and cos theta by sin theta. 1 by sin theta is nothing but cosecant theta. Cos theta by sin theta is nothing but cot theta, which was your RHS. Clear, people? So with this I completed the essay questions given in Abyasa Deepika. Okay. So after this we shall do part B questions of Abyasa Deepika of trigonometry. Okay. So I will share the notes of this in Math Facilitator website, and you can check it again also, and you can practice it, and I will also share Abyasa Deepika practice questions on the site as well, where you can mark the answers and check whether you learned it or not. Okay. So do use it to the fullest extent and do learn properly. Okay. Don't waste your time. So thank you so much for watching. Do subscribe the channel also. I am bringing lot many important videos for you, and do share it with all your friends as well. Do comment and let me know how are you liking the videos, because your comments matter a lot, and it gives me a lot of positive motivation to work for you. Okay, so like the video and share it with everyone. So thank you so much. Bye bye. Take care and keep practicing. Keep loving math, and do the hard work needed so that you score more. Thank you. Bye bye.